Hello, I want to show you a little project I've built. It's called Bluesky 100 Most Popular Words in the Last 5 Seconds. It's a thing that is possible because of Bluesky's protocol. So first I'm going to quickly show you, then I'm going to explain how this protocol works for this particular use case. So if you know about ATProto and the Firehose, you can skip this section. Then I'm going to quickly explain how WebSockets work. This is mostly for beginners who don't know about WebSockets. If you know about them, you can skip the second section as well. In the third section, I'm going to show the code and show how this little project works. So basically, it's a completely in-browser, so no backend thing that gets all the messages from Bluesky in real time. And every 5 seconds, it analyzes all of the words and finds the most common and most popular words, and then shows you 100 of them. So right now it's morning in Europe, and it's interesting to see what people are talking about. Most of the time there are words like good and love and people in the most common words, and it's interesting because that's a social network, right? People are not talking about good and love, but Bluesky so far is a bit different. It's not so huge, it's growing fast. So if you don't know at all, it is like Twitter. It's a microblogging platform. It looks very similar to early Twitter. It has some interesting differences though. So yeah, by the way, this is my account. If you want to follow me, I write about like quantum computers and programming. It's built on top of an open protocol called ATProto, and they have a documentation about this. It has a potential to be decentralized, or you can already have like your own node compatible with this protocol. But so far, Bluesky itself is centralized. It's just a company that runs a service, you upload data to it, etc. But the protocol they develop, it's open. There are lots of open source tools to consume it and to contribute to it. And it's kind of like a Git repository. So they even call things very similar to how you call things in Git. Basically, every user or every account has a repository. And everything that happens in that repository, like a new message is added, you like something, you follow someone, you unfollow someone, you upload an image, etc., is an event that is committed to that repository. And that commit has some fields. And then in the protocol, if you connect to the repository, you can receive messages, which are these commits. They are stored in a smart way. They are stored in a way that is very similar to how Git stores them. So how does this work? Well, one of the things that is part of this protocol, well, not really the protocol, but what Bluesky does with this protocol is called a Firehose. It's a stream of events that is mainly used to sync between nodes. So there's one node, there are some accounts there, and people are doing something, and everything they do gets into the stream of events that is streamed to other nodes, and then they can keep in sync. What's interesting is that, well, Bluesky itself, like this main server, also has a Firehose, and you can consume it to just receive all the public messages and everything that happens on the network, basically. The way you consume it is a bit difficult. Well, it's a WebSocket that they offer, but the things that are being sent on that WebSocket contain lots of technical information. So it's not just people's posts or images. It's everything that happens on the network. It's like follows, unfollows, some technical information, metadata, stuff like that. So it's a lot of information. You can consume it, but it's difficult. So people who are consuming it are able to build some interesting things. Like this is, for example, a very cool 3D screensaver kind of thing. with messages pulled from real time. Like these are actual messages that people are posting right now on Bluesky, which is quite interesting. And this always happens with projects that open some sort of very rich API for developers, is that it starts with just these kind of fun games and cool, showcases of what you can do. Like mine is similar. This is just a toy. But then it gets more serious, or people get to build something cooler, maybe not cooler, but more practical, something that you can actually use on a daily basis to do some useful things. So one thing about this protocol, which is cool, is that you can extend it. For example, you can build let's say a blogging platform on top of Bluesky. And even though the messages on Bluesky, like on Twitter, have a limit, like it has a 300 character limit, the protocol itself is extendable. You can extend it. You can add things, you add new fields to it. You can upload files to this node, and you can, have a new field that would contain more text or something. So there are actually developer demos. I'll link some in the description, and the tutorials from the actual Bluesky team that show you how to build like a separate kind of social network on top of this protocol and on top of all the infrastructure that already exists for this protocol, which is pretty exciting. And they even have this call for developer projects where they describe what kind of things you can build and what kind of things they are maybe suggesting you to build. Like you can build some review and recommendation things. Like, I don't know, you could add an ability to review anything that exists and identifiable, like movies by their unique identifier or places by their coordinate, something like this. You can build, like there are more ideas, and this is all possible. Like they describe dozens of different use cases and possible apps, and it's possible to build them even today on top of this protocol, which is exciting. So far, Bluesky is a breath of fresh air in terms of what they offer as a company, what they offer to developers, and what they offer, and like the audience actually that is there. It's quite cozy right now. There are not too many bad people, but it's very easy to filter them out. And as long as the team behind it doesn't get like completely psychotic, which is, I know it's a very low bar, but here we are today, it might be an interesting place. So I'm quite excited about it. Anyway, the Firehose. The Firehose is lots of data and a bit difficult to process. So this fine person, which I believe works at Bluesky, they are one of the network architects or some sort of like important architects of the system, wrote this blog post, and it describes how roughly this Firehose works, and then also how it's possible to actually cut the amount of data in it by 99%. Well, it cuts some of the data that is not useful to my use case, for example, or many use cases that people would like to use it for. And basically it becomes just different WebSocket. And every event on that WebSocket is a friendly JSON, which just consists of some fields, and they describe messages of people on Bluesky. So this, for example, is a message that someone with this unique identifier, this is the identity ID of an account, liked something. So the type was like, and then some information of what they liked. And it's quite amazing. There are about 21 million users on Bluesky right now. I don't know how many are active, but the network seems quite active today. By today, I mean like last 2 weeks. And if you start consuming messages from this WebSocket, in about a day, you get like few dozen gigabytes of data uncompressed, which is quite cool. You can do lots of interesting stuff by analyzing the data. So yeah, before I show you how this code works, the second section now is for beginners who don't know what WebSockets are and how they work. So this is just a short overview. It will be easier to understand how the code works. So a WebSocket is a protocol. As you can see here, instead of something like HTTP or HTTPS, you see WSS. So it's WebSocket, and S also stands for the same thing as in HTTPS, meaning this is encrypted. And it's a protocol that is not HTTP, but you need HTTP to start working with it. It's a streaming bidirectional protocol where you initiate a connection, you get connected from the client to the server, and now both the client and the server can independently send messages to one another. So it's kind of like a phone call where you connect somewhere and then you can speak and they can speak. But unlike a phone call, if you speak simultaneously, you can still understand each other. So the client can speak and send some message to the server would react to that message while also possibly sending messages to the client. And this is a useful protocol if you need to build some sort of real-time thing on the web. Like if you want to build a chat in the browser, you could still just use HTTP. But the problem with HTTP is that, first of all, it's a bit more expensive to send full HTTP messages or requests. And second, there's no way for the server to send a message to you unless you ask for it. So if you were to build a chat, which is kind of real time in the browser, and you only use HTTP, that means you would have to send messages, like get messages to the server on a short interval repeatedly to just check if there are new messages. If you use WebSockets, then the server would just send the message to you as long as you keep the connection open. And the connections with WebSockets are meant to be open for a long time. So you can open it and then keep it alive for hours. So why do you need still HTTP? The way you get a WebSocket connection is you have to first ask the server if it's even capable of it or if it's accepting this kind of connection, and then ask to upgrade your HTTP connection to a WebSocket. And for this, you need at least HTTP 1.1, which probably everybody has now, every single system. But to be clear, HTTP 1.0, you cannot have WebSockets there because in that version of HTTP, every single request and response would open a separate TCP connection. A TCP is just a lower level networking abstraction. And this was bad because this is more expensive or more heavy for the server to process. A TCP connection is like a bigger thing to process system-wise. And also it takes more time because you have this additional kind of connection for every request and response. You cannot have a connection and keep multiple requests within that connection. With HTTP 1.1, you can. You have an ability to, or the server and the client, they manage this automatically, but you have an ability to open a TCP connection and then have multiple request responses. And this is good. For WebSockets, we want that within one TCP connection, but for, as I said, maybe hours. So the way it works is that the client should send this kind of get HTTP message to the server, and it should explicitly ask, I want to upgrade my connection to this type of connection, to WebSocket. And if the server is happy with this, the server would say switching protocols, send this one-on-one response flag, and then also say, yes, I'm upgrading this connection to WebSocket. These are some technical things which not super important now. This is basically a very smartly generated random number. And then both the client and the server can send messages, and the messages can contain data and must also contain some metadata, and the metadata should be in a certain format. As long as the client and the server are sending messages in the correct format as per the official RFC description of how this protocol works, the protocol is kept alive and it works. If someone violates this, then the connection dies. So, yeah. Finally, how this works. It's just a page. As I said, no backend, and just simple JavaScript on the browser. It consumes that jet stream, this lightweight Firehose. Stores all the messages in memory. And every 5 seconds, it pulls all the messages from the last 5 seconds. And for each message, it finds out what are the words. And then once all the words from all the messages are extracted, it finds the occurrences of each word. And then 100 most popular words, most occurring words, are put here in the order of appearance. So I can pause this and I can resume it. And here at the bottom, we have like a debugging tool. It shows 100 last messages. And by message, I mean both the messages that are received from the people, like their posts on Bluesky. I think I just cut them to 50 characters here. And then some messages that my app tells me, like when I hit pause, the WebSocket disconnected. I also have this status thing. And once I resume, it's connected here, and I start getting messages. And this is just a count of how many messages I processed. So it's quite interesting how, depending on the time of day and maybe depending on the news, you would see different things. If there's some big thing happening in the world, you would see probably a word or some last name here. You can still see that many people are very much into US politics, like it's a thing, I believe. I don't know what happened. There was some event. I don't know. Anyway, the code is just a simple web page, HTML page. It's barely 300 lines of code. And actually, like half of it you will see is not core. So some styles, whatever. By the way, this code is, of course, on GitHub. The link is in the description. Feel free to build on top of it or just check it out. So now I just put these divs for all these components, and they will be populated by JavaScript. There's no React, nothing, just vanilla JavaScript. By the way, I found out that some people seemingly say vanilla JavaScript and they mean Node.js, which was mind-blowing to me because I always thought vanilla JavaScript is, well, browser. This is where JavaScript started from. This is its home vanilla place. But yeah. Okay. What is our vanilla JavaScript? OG vanilla. This would be the array of all the posts. This is just a counter of how many messages I received. This is an array of things to be then rendered here, this debug window. This is to hold a connection to that WebSocket. And this is just a global flag, which indicates whether this pause is pressed or not. This would be for the interval, for this thing that in the browser JavaScript does things every X milliseconds. So this is the URL of that Firehose lightweight jet stream and some things you can configure. The cloud size is the number of words that I want to have in this cloud. So I want 100. Okay. And then just selecting some things that we want to access on the web page. And this little function called log just gets the current timestamp, gets some string you send to it, and adds here. Okay. So one huge portion of it is so-called common words. They also sometimes called stop words. So every time you want to process some sort of text, for example, to extract tags from it or categorize it or just analyze in some way. Usually you would like to not care about words that don't bring meaning on its own. Depending on the language, there are more or fewer words like that. For example, in English, these are all these particles and articles like the, and also words like can, cannot, do, don't, doesn't, etc. If you don't ignore them, then chances are one of the most common words would be do or can, and it's not useful in our use case especially. So we want to filter out these kinds of words. You can find libraries with collections of these words for various languages. You can just Google some. I found a website with seemingly an okay list, and I just copy-pasted it. I also added things like www, and yeah, maybe some of them shouldn't be here, like thanks, thank. I don't know. But yeah, the most important thing, and you can tweak this to your liking, is to remove words that absolutely have no meaning. And then also need to do the same for Portuguese. And the reason is that Portuguese is probably the second most common language on Bluesky because there are apparently a lot of users from Brazil. I think this happened mostly after Twitter was banned in Brazil. Looking at this word cloud, you can see there are more languages actually. At least I think this is Arabic. Depending on the exact time that you look at it, sometimes you can see, oh, the Korea woken up, something like this. It's interesting. So yeah, it's also possible to kind of detect the language and maybe have some filters, maybe show me only most common words in English, or at least in Latin-based alphabets. I didn't do it here, but maybe you could do this yourself. All right, and by the way, this is a set generated from this array. Then we have this function to update the status, and it does a couple of things. It logs something onto this log window, and then it changes the status of this indicator, both the color and the text. And here's the most important part. It's the connect WebSocket function. Once you call it, if there is already a connection, we want to kill it because we want to reconnect. Then we update status to connecting. This happens when you, for example, hit resume. It says connecting and it's orange for a few moments. And then this new WebSocket thing returns a WebSocket connection object. And on that object, you can have callbacks. And most important ones are on open, on close, on error, and on message. And they are exactly how you would imagine. They accept a function that would be called on that event. So on open, we don't want much, but just say the status is updated, and the same for on close and on error. The core, the bulk of the logic is on message. Every time we receive a new message from this jet stream. And this happens like multiple times per second. So what we want is to increase the count, which is shown here. Then get the data. So we know from the specification that this jet stream gives us this kind of JSON. So we have to parse it because it comes just as text. It's in the event that is sent to the callback, and the data field of that event has the data. As I said, this could be different types of data. So we don't care about likes, we don't care about some other things, we just care about actual texts. And this is the type post per specification. And then also that post might not contain text. It's possible, I guess, you can just send an image and nothing else, and then there would be no text to analyze. So we also want to check if the commit of this message has a record, and that record has text. And by the way, these question marks are so-called optional chaining things in JavaScript. The reason you would like to have them here is that if you didn't have them, for example, you did this, then if there's no commit in data or there's no record in commit, you would get an exception. You would fail within this famous JavaScript type of error where it would say attribute text not found for undefined, because this would be undefined. If you use these question marks, then the whole thing would collapse to undefined and not raise an exception in case any of these are null or undefined. So this just avoid that. This makes it possible for you to not have these checks. If commit, then get record. If record, then etc. So if the message that we received as a text and is a post and it has some text, then we push a new object into our global posts array. And that object would have the text that we got and the current timestamp. Now, I'm cheating a little bit here because the message itself has a timestamp, but I guess I didn't want to parse it. I don't know why. Anyway, I think it doesn't matter for my use case because I just care that I got to process 5 seconds of messages from my point of view. So once I receive a message, I treat it as I received it right now. And then I want to keep this posts collection from growing too much. So here I limit it to either 10,000 documents or just last 5 seconds. And whichever comes first. So yeah, I just delete one message from the beginning if one of those conditions satisfy, and then just log some data. And this data is actually, what is it? Yeah, the text, a substring of text. What I wanted to show is this. Okay. So update word cloud is the next function, and it calculates all these common words. So for each word of this, for each post of this posts collection, I get the text of that post, lowercase it. So I don't want to compare and treat words that are spelled with different casing as different words. I want them to be the same, so I lowercase all of the words. Then I remove all the punctuation and symbols and emojis and symbols like this, I don't know, copyright symbol, something like this. So I don't care about any of those. Then I split the message into separate words. And then for each word, I want to filter out something. First of all, I don't care about single letter words. I guess this makes sense. I also don't care about huge words. Sometimes there are messages that have like no white space, like a huge sentence all in one word. Another reason is that, and so far this is really bad treatment of like non-Latin based languages, because from the point of view of this logic, something written in Chinese or Japanese, a word could be very long, but it's not a word, right? From that language, it's just a series of symbols that has no white space. So maybe there should be some different logic to properly process languages other than, Romance languages or Western languages. Okay, then I want to filter out those stop words that I showed you before, and also things that look like a link and things that look like hashtags. And then I construct, or like I add to a collection of words with their counts. So this word count thing is an object that looks like this, where there is a word and then the number of occurrences of that word. And the way I do it is that I take all the words from the post, and for each word I find it in the word count. It maybe is already there, in which case I increase this number by 1. Or if it's not there, then that would create it, and then it would get like 0 plus 1, because this would say no, undefined. So it would get 0, and then plus 1, 1. This would be our first occurrence of the word. Then we want to sort this kind of object by number of occurrences. And this is a bit cryptic, but so the sort function can accept a function which will be used to sort a collection. And that function should accept two arguments, and it should return which should come first in this sorting logic. So this destructuring thing means that when this anonymous function would get 2 arguments, which are 2 objects like this, a word with its number of occurrences, I want to get the occurrences from one and occurrences from the second, and then compare them like this. So this would get me sorted words in the correct order and limited to the cloud size, which is 100 for us. So, for example, if we were to treat this collection and we were to put this cloud size to 2, and here we have 3 words, then we would get what? I don't know why something happened in the background. We would get world with 10 as the first, and then hello as 5, hello with 5 as the second, and no test 3 because it's smaller than those 2. Okay, I think this is mostly it. Then we have to actually render them on the page, do all of this. And as you can see, the size of font goes down slightly as you go from the most common to the least common word. And also the background is changing. So the font size is straightforward. I just want to start with some font size and slowly decrease it to the 100th word. So I do this kind of thing. I start with a base font size of 1.2 EMs, which is font size relative to the parent element in CSS. And then I take the position of my word in this list of 100 words, and for each position element I add 0.01 EMs. This gets to something like 1 point something, and this last one would be almost like 1.2. The color is a bit more tricky because I wanted the color to be actually reflective of how popular the word is. This seems kind of nice gradient, but sometimes, let's say, again, some news happens or something big, and then one word becomes like very popular, like dominant. It would still be just the first word in the list, but it's heavier than other words. And that the background of that word would be more deep, like more solid. And for this, I have to have this max count, like the word that has the most common occurrence. What is the occurrence? And I want to compare it to the occurrence of this word. And then have this strange formula that calculates the opacity, and then I apply this opacity to the the background color. So I do this for each word in the 100 of sorted words, and for each word I add it to the container, which is this white background container. And then just some event listeners for the buttons. So what happens when you pause, when we resume. It's just exactly what you expect. And in the end, once all those functions and globals are defined, I want to connect WebSocket. So on page load, it starts. You don't have to press anything. And then the first update, I want to be actually 2 seconds. Because once I load the page, I don't want to wait 5 seconds. It's kind of too long. But then after that, I want this to update every 5 seconds. So this is what it does. It updates after 2 seconds and then sets this interval to 5 seconds. Because this cloud update interval is defined here. So that's it. And it's a nice toy. Now I'm thinking a more interesting thing would be to actually to have a backend and to store these trends. Now imagine being able to scroll back into the history to any hour of the day of the past and find out what are the most common words that the whole network has been using. It's kind of like Google Trends thing, right? You know, this thing where you can put some words and show how popular that word was in Google searches over the time. This is kind of like that, but it's what people were talking. Maybe. Let me know in the comments. Maybe we can also build this live on YouTube. That's it. Thanks. Bye.